In today's show, we uncover the mystery of satellite-based astronomy and talk about ASTROSAT. Hi there, I am NTP and you're watching The Spectator Show. Now, one of the most popular topics in news these days is the ASTROSAT launched by ISRO, and I'm sure most of you must have heard about it. But is it really that big a deal? To describe ASTROSAT, we can say that it is a science mission focused on multi-wavelength study of outer space. Or in simpler words, it is just another IRS-class satellite with a small difference that instead of looking back towards Earth, it looks into the space. Well, it is not the first time an observatory has been launched into space, some well-known names being Hubble and Spitzer. It is certainly the first time for India. Actually, it is a lesser-known fact that the evolution of ASTROSAT is based upon Indian X-ray astronomy experiment conducted back in 1996. ASTROSAT is designed for broadband astronomy covering visible, near UV, far UV, soft X-ray and hard X-ray regions of the electromagnetic spectrum. A high-energy radiation study cannot be performed from a ground-based station due to the fact that most of the UV and the X-rays are lost due to absorption by the atmosphere. This is where high-altitude weather balloons and satellites become important for scientific observation. The lift-off mass of the spacecraft is 1513 kg, out of which 832 kg is the mass of the instruments. The rest of the weight comprises of the power equipments, transponders, and propellant for a 5-year mission life. ASTROSAT is being launched by the XL version of the PSLV C-30 rocket into a near-Earth equatorial orbit at an altitude of 650 km and an inclination of 6 degrees. Now, one may raise a question here that a similar Chandra X-ray telescope by NASA has a perigee of 14,300 km and an apogee of 134,500 km, which provides it a very long continuous observation time as compared to ASTROSAT, which on the other hand cannot be said to track a particular object in space for more than 50 minutes. But is it necessarily a bad thing? Actually, it is not. The thing is, ASTROSAT is a general purpose observatory, not meant to look closely, but to provide a broader general picture of the observable universe. And secondly, with a shorter orbital period, it can view a given part of space 14 times a day at regular intervals. This can help us track any changes that occur in that part of space with better accuracy. The other term associated with the orbit of the spacecraft is the inclination of 6 degrees. There can be two reasons for that. First, it is done to extend the workspace of the spacecraft. That is, if the observatory orbiting in an equatorial orbit with zero inclination has a permitted observation space of 60 degrees about the direction of motion, then an inclination of 6 degrees can add the same amount of observation space in both hemispheres. The second reason can be to provide a better insight into the charged particle anomaly over the southern Atlantic Ocean, which would not be possible with a zero inclination. Coming back to the point, if all goes well and the weather is supportive, we will have a launch on 28 September at around 10 AM. The ground command and control center for the mission is located at ISRO Telemetry Tracking and Control Network in Bangalore, and the tracking is provided by the Indian Deep Space Network at Bengaluru. At an average, ASTROSAT will generate about 440 GBs of data per day, which will be downloaded during the visible orbits via an 11-meter antenna at IDSN. This mission is being described as proposal-driven observatory with scientific focus on simultaneous multi-wavelength monitoring of intensity variation of broad range of cosmic sources, monitoring the X-ray sky for new transients, sky surveys in hard X-ray and UV bands, broadband spectroscopic studies of X-ray binaries, AGNs, SNRs, clusters of galaxies and stellar coronae, study of periodic and non-periodic variability of X-ray sources, and observation of charged particle anomaly over the southern Atlantic Ocean. Let us now look into the instruments being sent with ASTROSAT for the purpose of achievement of scientific objectives. The first being the twin ultraviolet imaging telescopes with an aperture of 380 mm each. This instrument will study the visible, near UV and far UV bands of the spectrum one at a time by using a combination of filters. Second instrument is 3 units of large area xenon proportional counters covering the medium energy X-rays. As the name says, it is a proportional counter. That is, it evaluates the number of same energy photons incident with respect to the whole band. LAC-SPECI has the maximum effective area of 6000 square centimeters at energy values of 10 kilo electron volts. The next one is soft X-ray water telescope with conical mirrors and an X-ray CCD sensor, covering the energy range of 0.3 to 8 kilo electron volts. The maximum effective area in this case is around 128 square centimeters at 1 kV. Fourth instrument is the cadmium zinc telluride imager covering the hard X-ray region of the spectrum with energy values from 10 to 150 kV. It also incorporates a normal incidence sensor with efficiencies close to 100% and an effective area of around 480 square centimeters. Fifth instrument is a scanning sky monitor consisting of 3 position-sensitive proportional counters with coded mask. This whole assembly will be placed on a rotating platform to scan the available sky once every 6 hours so as to locate any transient X-ray source. A charged particle monitor has also been included as a payload in order to study the South Atlantic anomaly region, which has high fluxes of low energy protons and electrons. The data from CPM will help preventing any damage to other equipments due to the anomaly. All these payloads of the spacecraft work in unison in order to provide a broad spectrum map of the outer space. At the same time, ASTROSAT itself works in coordination with land-based visible and radio telescopes to obtain a full spectral analysis. A number of organizations have been involved in the development of ASTROSAT. A few of the notable names are ISRO Satellite Center, Tata Institute of Fundamental Research, Indian Institute of Astrophysics, Raman Research Institute, Vikram Sarabhai Space Center, University of Lancaster, Canadian Space Agency, Laboratory for Electro-Optics, and Inter-University Center for Astronomy and Astrophysics. At last, we arrive at the final question. Will the observatory be open for public research? The answer is yes. While the first year is fully occupied with performance verification phase and guaranteed time, Indian proposals will be entertained from second year. However, foreign institutes like CSA and University of Lancaster enjoy reserved time in the program. On final note, I wish the ASTROSAT program a success so that young minds of India can be inspired to take astronomy as a subject and make a life in space research.